Alright, before we go on any farther, I want to talk about some strategies for evaluating limits analytically. So I've got some examples here, including two we've already looked at. In the first one, you've got the limit as x tends to 2 of the quantity 3x squared plus 5 divided by x squared plus 7x plus 1. So when you're looking at this and you're thinking about what to do, what I would try first, especially if all the functions involved are fairly nicely behaved, and we'll talk more about that later, but what I would do in the case where all the functions involved are nicely behaved is I would try substituting in the given value of c. So for instance here, we're trying to determine what is happening to this function as x tends to 2. Well, let's just plug in the 2 and see what happens. If you substitute in 2 for x, you're going to get 3 times 4 is 12 plus 5 is 17, and in the denominator you're going to get 4 plus 14 is 18 plus 1 is 19, and so that limit is 17 over 19. Now if you try the same thing with these other two limits, which we have already explored, you're going to get something quite a bit different from what you got up here in this example. So if you plug in 1 for 0, if you substitute in 1 for x in this example, you're going to get 1 plus 1 is 2 minus 2 is 0, and in the denominator you're going to get 0, so you get 0 over 0. Down here in this example, the third example, x squared minus 16 over x squared minus 4x, that limit as x tends to 4. If you substitute in the 4 for x, you get 0 over 16 minus 16 is 0 again. So you're getting 0 over 0 in this case and 0 over 0 in this case. In the event that you get 0 over 0 when you substitute in the given value of c in for x, what that's telling you is that there is more to do. 0 over 0 is what's known as an indeterminate form. And what that's saying is that you cannot tell just from this form what the limit is going to be. It could be 3 as in this example, or 2 as in this example, or it could be 0, or it could be that the limit doesn't exist at all. You don't know just from that form 0 over 0. So let's look at some more examples. In this one you've got the limit as x tends to 2 of 1 over x minus 1 over 2, and then that's divided by x minus 2. We're taking the limit as x tends to 2. So if you substitute in 2 for x, you're going to get 1 half minus 1 half in the numerator, that's 0, and in the denominator you're going to get 0 again. So this is of the form 0 over 0. That is not enough to tell you what the answer to this limit is, what the value is, or whether it even exists. So what we need to do is some algebra. In the previous examples we've seen, what we were able to do was some factoring, and that was enough to let us simplify the functions involved, and we were able to evaluate the limits. Well, in this case, what we ought to do is find a common denominator for this numerator, 1 over x minus 1 over 2, and combine those two terms. So the common denominator for x and 2 would be 2x. Alright, so I'm going to rewrite the function, and let's see, that would be 2 over 2x minus x over 2x, and then we still have x minus 2 in the denominator, and I'm going to continue on simplifying. So what we're going to have in the denominator is 2 minus x over 2x. And now we're dividing by x minus 2. Well, you can think of x minus 2 as x minus 2 over 1. And we can, instead of dividing by x minus 2 over 1, multiply by its reciprocal, 1 over x minus 2. Well, what you notice here is that you've got a 2 minus x and an x minus 2. I hope you remember that these are equal except that they have opposite sign. So what we can do is factor out a negative 1 from say the numerator, which would leave negative 2 plus x, and then the denominator will be 2x times x minus 2. Negative 2 plus x is equal to x minus 2, so these two can go away. And what we're left with is just the limit as x tends to 2 of negative 1 over 2x. And when we substitute in 2 for x here, we're going to get negative 1/4. Alright, let's try another example. Here we have the limit as x tends to 3 of the square root of x plus 13 minus 4 in the numerator, and in the denominator we have x minus 3. I think I'm going to rewrite this on another sheet of paper so that I will have more room. If we substitute in 3 for x, we're going to get the square root of 16, which is 4, minus 4, or 0 in the numerator, and we're going to get 0 in the denominator. This is our indication to do some algebra or something else. We're not done when we get 0 over 0. Alright, so in the case where you have a square root plus or minus a term, what you can do is use what's called the conjugate of this expression. And by the conjugate, let's see, if you've got a plus b, the conjugate would be a minus b, and if you have a minus b, the conjugate would be a plus b. So what we need to do is multiply the numerator of this fraction by the conjugate of the numerator, and then multiply the denominator by the same expression. So what we get is the square root of x plus 13 minus 4 times, and now we need the conjugate of this, so that's going to be the square root of x plus 13 plus 4, and then the numerator is complete. So let's go down to the denominator, and we're going to multiply x minus 3 times the square root of x plus 13 plus 4. Now, what we would like to be able to do is cancel something out. Well, in order to cancel something out, we're going to need to multiply the numerator out. So if we multiply that out, we're going to get the square root of x plus 13 times the square root of x plus 13. Let's just call that x plus 13. We're going to get plus 4 times the square root of x plus 13 minus 4 times the square root of x plus 13. That's good. These will add up to 0, and actually that's why we chose to the conjugate to multiply by. And then we're going to get negative 16. And the denominator, let's just leave that as it is, because if we want to cancel anything, we're going to need to have this factored already, and so we don't want to undo any factorization. unnecessarily. Alright, so if we clean up the numerator, we should get x minus 3. More good news, because we have an x minus 3 in the denominator. So this expression simplifies to the limit as x tends to 3 of 1 over the square root of x plus 13 plus 4. And now we can substitute in 3 for x, and we get the square root of 16, which is 4, plus 4, or 1 over 8.